So guys, now next we will going to discuss the concept of strict alternation. So strict alternation is nothing but it is the pattern of execution of threads, and we will going to discuss the implementation of strict alternation using semaphores. So it is of practical significance to make a pair of threads to execute in a strict alternation manner, right? So note the words pair of threads. This problem applies to only two threads, right? It is not uncommon in the software world to implement this pattern of execution between the two threads. And that is the reason that why strict alternation finds a special place in the discussion of thread synchronization. So pictorially, you can see that we have the thread T1 and we have a thread T2. When thread T1 executes and do work, let's say W1, the thread T2 is in the blocked state. And when the thread T1 finishes its work W1, then it gets blocked, and it is the thread T2 which resumes its execution and do W2 amount of work, right? Then thread T2 block itself at this point, and it is the thread T1 which resumes its execution and do W3 amount of work. And this cycle repeats for forever, right? So as you can see from this diagram that only one thread executes at a given point of time, right? And here the other challenge is that when the one thread finishes its execution, how to convey to the other thread to resume its execution, right? And when the other thread finishes its work, then how the other thread will convey the former thread that I'm done with the work, you can resume with your execution, right? So we need to implement the scheme using semaphores in which threads can execute in strict alternation manner, right? So we will going to use the concept of semaphores, and more specifically saying we will going to use zero semaphores to implement the solution of this problem. Now the question is, what are zero semaphores? Zero semaphores are nothing but they are semaphores which are initialized with the permit counter value as 0, right? So what is the special thing with the semaphore? The special thing is that immediately after the initialization of such a semaphore, if a thread invokes SemWait API on such a semaphore, the calling thread is immediately blocked, right? Because the value of the permit counter will go from 0 to -1, and as per the rules of the semaphore, the calling thread gets blocked, right? On the other hand, when the thread executes SemPost operation on a 0 semaphore, then its permit counter value would increase from -1 to 0, and whatever thread which was blocked on that semaphore would resume its execution, right? So you can see zero semaphores gives us the simplest way to block the thread and signal the thread, right? The thread T1, if it is executing and at some point of time in its execution flow, suppose the thread T1 invokes an API SemWait on a 0 semaphore, then the thread T1 would get blocked at this point, right? And if other thread in the system simply invokes SemPost API on the same semaphore, then the thread T1 would resume its execution, right? So this is how zero semaphores work. So now let us solve a problem which is based on strict alternation. Let us suppose that you have this problem statement. Write a program which create two threads T1 and T2. T1 thread prints odd number between 1 and 15, whereas the thread T2 prints even numbers between 2 to 15. And the output that you should see on the screen must be sequential. That is, the output should be 1, 2, 3, 4, up to 15, right? So your output should be strictly sequential. So the solution of this problem is that you need to synchronize the thread T1 and T2 in a way that they should execute in a strict alternate manner, right? So I would request just pause the video and try to attempt a solution by yourself, because now I'm going to discuss the solution to this problem. So please pause the video and think about the solution before going forward. So guys, now I will going to discuss the solution to this problem. So you can see that the solution is quite straightforward and simple. You need to use two semaphores and both the semaphores are zero semaphores, right? So this solution requires you to take two zero semaphores. And now I leave it to you to go through this implementation of thread T1 and thread T2 and verify whether this program would print the output 1, 2, 3, 4, 5 up to 15 or not. And if you think that this piece of code really gives the correct solution, then I would suggest that give a second thought to this solution or to this piece of code and think about it, that why zero semaphores is able to solve this problem so gracefully. The reason I'm asking this is because we will going to use zero semaphores in the sequel part of this course to implement a subset of the strict alternation and see how practically zero semaphores help us to actually solve certain thread synchronization problems.